I'm back with the Elgin pocket watch. If you remember from the last video, I had stopped working on it because I had put the second hand on a little bit too tight. I pushed it down too far and it was rubbing on the dial, which was keeping the mechanism from working. And so when I pulled the second hand off so that I could reset it properly, the spindle that it rides on snapped off and broke off inside the little tube on the second hand, ruining the second hand as well. And so I said I was going to try to get another fourth wheel, because the fourth wheel is what carries that spindle. It's on the bottom of the fourth wheel. And once I replace that fourth wheel, then I would put the watch back together and we'd be done with it. Well, I've been looking for probably a month or so now for a fourth wheel for this, and I cannot find one anywhere. Nobody in the world seems to have a fourth wheel for a Unitas 6431 or 6445. Both movements use the same fourth wheel. And so what I decided to do, because I don't know how long it's going to be before I can actually find one, and I'm tired of seeing this thing sitting on my bench in pieces, I put it back together with the old fourth wheel, because it still functions as a fourth wheel as part of the gear train. It just won't carry the second hand. And so the watch is perfectly functional now in all respects except that there is no second hand. The minute hand and hour hands work and they tell the time correctly. So what we need to do now, what we didn't show in the previous video because I was hoping to find that part, was how to case the movement back up. We did show earlier putting the dial and hands on. I've done that now. The case has two sides. One side is the back side and one's the front side. The back side, or the front side, is deeper and has a little ridge around the inside that the movement sits against. And that's the side you want to put it in. This is a front-loading case, which most pocket watches are. And so what we're going to do is just drop the movement into the front, and then turn it so that the 12 is aligned with where the crown is going to be when we push the stem back in. And then we can put the cover back on it, the front cover. And the bezel and crystal are together and they screw on. Once we've got that screwed on, then we can turn around and look at the back side. The first thing we need to do is put the stem and crown back in. And I want to do that before I put the case screws in, because I need to make sure that everything's perfectly aligned, because this can turn in the case, and I need to be able to maybe turn it slightly to get the stem aligned. So the first thing I need to do is I need to loosen this little screw right here, which is the stem retaining screw. I don't want to loosen it too much because this also is the screw that holds in place the detent lever on the dial side of the movement. If I loosen it too much, the detent lever is going to fall off, and then I'm going to have to take the hands and dial back off to fix it. We're going to go ahead and do that. It should only take about one turn of that screw. And then I'm going to try to put the stem back in, see if it will go in all the way. Yeah, see the movement turned slightly when I pushed it in, so it wasn't perfectly aligned yet. It's not going quite yet. I don't have it aligned correctly, because you have to turn this so that the square on the stem goes into the square hole in the clutch. And I think what I'm pushing against here isn't the clutch. I think it's the detent lever, so I think I need to loosen the screw a little more. I had to loosen that screw off camera because I couldn't see very well to get the screwdriver in it, but I loosened it enough, took another one turn of the screw, and then the stem pushed right in. So now what we need to do is put in the two dial screws that hold the dial in place. There are two dial screws that hold the dial into the movement. One goes in right here, and the other goes in right here. And they overlap this little lip right here slightly, which the back of the movement rides up against. And so those will hold the movement in place. One nice thing about working on pocket watches is these parts are not microscopic like they are on a wristwatch movement. This is hard to do under the camera. If I were doing this without the camera, I would look at it through the eye loop and be able to see it a lot easier. And this would have just dropped right in. Alright, there we go. I want to get the other one started before I tighten it all the way. Alright, both dial screws are now tightened down tight. The next thing to do would be simply to screw the back on. But first I'm going to wind the movement up, make sure that everything works. And I did test it before I started this, so I know it's going to work, but let's go ahead and do it on camera. Start winding it. And there it goes, our balance wheels come to life. After I screw the back on, then I'll set the time on it. Actually, before we do that, we need to regulate it. And so I'm not going to screw the back on quite yet, but I want to have it fully wound before I regulate it. Okay, fully wound, ready to go. Now we can put it on the Timegrapher and see what kind of performance we're getting and what changes we need to make to the adjustments to regulate it. Here are our Timegrapher results for the Elgin Pocket Watch. Now, this has not been regulated very closely yet. I had played around with the regulation a little bit when I was working on it before, but decided not to finish the regulation until I had everything working. And it's showing negative 20 seconds per day, 233 degrees of amplitude, and 0.5 milliseconds of beat error. The amplitude is okay for a watch like this. When I had it in the dial-up position on the Timegrapher a minute ago before I started filming, the amplitude was a little higher than that, which it usually is. Right now I've got it in the 12 o'clock position up, or pendant up they call it, where the crown is facing upward. And usually that's where you want to regulate a pocket watch, because that's how they're usually carried in someone's pocket. When I had it set dial up, I was getting a rate of about negative 10 seconds a day and an amplitude of about 250. So the amplitude's a little lower in the pendant up position than I would like, but it's acceptable for a watch that's this old. Part of the amplitude problem may be the fact that the fourth wheel has that broken spindle that carries the second hand. It may be slightly bent or something, which could be robbing it of a bit of amplitude. So that will probably improve once I get a new part for it. Now the beat error is 0.5 milliseconds. I can probably get it better than that, but that's acceptable. But the rate being as low as it is, we can correct that. So I'm going to go ahead and take it off the Timegrapher and work on the regulation. This watch, fortunately, is going to be easy to regulate because it has a modern regulation system that makes correcting for beat error and such a lot easier than on some of the other vintage watches I've worked on. Some of the other watches I have don't have an adjustable hairspring stud, so in order to regulate beat error, you have to take the balance wheel and hairspring off the movement and turn the hairspring collet, which is what attaches the hairspring to the balance wheel's balance spindle. And that's a difficult thing to do without messing up the hairspring. And it's also tedious because you have to take it off the movement, make an adjustment, put it back on the movement, check it on the Timegrapher. If it's not right, take it off, make another adjustment, and so on until you get it right. With this type of a regulator that's used on more modern movements, this was made in the 1960s, which is around the time they started using these type of regulation systems. There's two levers on the regulator. This one right here is one that carries the hairspring stud. And this one is moved to adjust for beat error, and then this one over here is the regulator pins, and you move it to regulate the rate. The thing with beat error is that the Timegrapher tells you how much beat error you have, but it doesn't tell you which direction it is. You can move this to the right or to the left, and you don't know which direction you need to turn to cancel that beat error out. So you have to try one and see what happens. If the beat error reduces when you move it the direction you try, you're doing the right thing. You can try moving it a little further that direction if it's not perfect yet. But if it gets worse, you know you went the wrong direction, then you have to go back the other direction and keep trying until you get it right. And when you adjust the beat error, it changes the rate as well. The beat error adjustment affects the rate some, so you don't want to adjust the rate first. You want to adjust the beat error first. And then once you get the beat error as close to perfect as you can get it, then you can adjust the rate. I'm going to move this hairspring stud. I'm going to move it slightly this direction to start with, to see if that works, and we'll put it on the Timegrapher and see how that does. I want to try to get it to lower than the 0.5 milliseconds. Okay, that adjustment made the beat error a little worse. Now it's at 0.6 milliseconds, up from 0.5, so we're going to move it the opposite direction and see if that gets us closer to where we need to be. The first time I moved the hairspring stud carrier counterclockwise, and that made the beat error a little worse, so I moved it clockwise, and I went too far. I got it up to 1.4 milliseconds then, so then I turned it counterclockwise again, a smaller amount, and got it down to 0.0. I got perfect beat error. Now our rate is now still negative 21 seconds a day. Amplitude's a little better now, 248. So I'm going to have to correct the rate now, and that's actually a lot easier to correct than the beat error. And I'll show you how that works. As I mentioned a minute ago, the hairspring stud carrier is for adjusting beat error, which we've now got perfect, and then the regulator pins carrier is for adjusting the rate. Now the rate right now is about negative 20 seconds a day. And this is actually a lot simpler to do because the Timegrapher tells you whether it's positive or negative. And so you know which direction to turn the regulator then. If you turn this counterclockwise, it goes toward negative, which would make the watch go even slower. We don't want that because we're already too slow. If you move it clockwise, it goes faster, and that's what we want to do. Now you don't want to move this too much. Even a teeny amount will make a big difference. If you move it enough that you can actually see it move, you're probably going to make a change of about 45 or 50 seconds a day, which is going to be more than we want. So what I do is you want to just barely press on it a little bit to get just a microscopic movement of it, and check it on the Timegrapher again, and keep doing that until you get it right. Because like I said, if you move it far enough that you actually see it move very much, it's going to be way huge amount of change. The only time you want to do that is if you have one that's already starting off way off. If you've got one that's starting off, you know, a minute and a half slow or something like that, then you want to push the regulator a little bit so you can see it move slightly. But if you have one like this one that's only like 20 seconds a day, you don't want to make that big of a change. Alright, this is a bit of a pain to regulate because the regulator on this wasn't real stiff like most of them are. Most of them take a bit of force to move them much, but this one I barely touched it and it moved a bunch, and it went to being from negative 20 seconds a day to plus 47. And then, so I did a bunch of back and forth on it, and I've got it now to where it's reading, was it plus 1, now it's at negative 2, so negative 2 is probably where it's going to stabilize, now negative 5, so I think it's going to stabilize at a little bit lower rate, because it's only been on for a few seconds. You should usually leave these on for about a minute or so to let it stabilize before you see the final reading. So I think I'm going to have to mess with it a little bit more, because I don't want it to be a negative rate. I want it to be either 0 or plus just a few seconds. But we're getting close though. We still got a 0 millisecond beat error. Amplitude's gotten a bit better at 242. And our rates looks like it's stabilizing at around 4 seconds a day, negative 4 seconds a day. To me, that's not quite acceptable. I want it a little bit higher than that. I want to try to get it to 0 or maybe plus 1 or plus 2, something like that. Looks like we're stabilizing really well. We're getting 1 second per day, 240 degrees of amplitude. I wish that was a little higher, but I'm not going to stress over that. 0 milliseconds of beat error is still good. Looks like our rate's going up to 2 seconds per day. It's not totally fully stabilized yet, but I think we're going to be pretty good here. I need to let the watch run for 24 hours too, and then check it again on the Timegrapher, because sometimes they'll drift a little bit until it's run for a day or two to get all the lubricants fully distributed through the system and everything. But I think that this is going to stay pretty well within tolerances that I can live with. Because we're seeing here plus 2, plus 3 seconds per day. That's good. That's really excellent for a mechanical watch, especially one that's probably 65 or 70 years old. So I think I can live with this. Let's go ahead and take it off the Timegrapher and put the back on it. Now that we have the movement regulated, we can go ahead and put the back on the watch. And this one's an easy one to put on because it's a screw-on back. Yeah. Easy to do, just screw it on until it's tight. The front screwed on the same way. This one's a really nice, easy one to work on compared to some other pocket watches that have backs that snap on and off. The old Waltham that I worked on that I wasn't able to finish because it has a broken jewel had a back and front that both snap on, and they were on so tight I had to press a razor blade into the crack between the case and the back and the case in the front to pry it open with, and that was a real pain to open. So I love these ones that are screw-on, fronts and backs, and I don't have the front tightened down. It looks like enough. Make sure it's all good. So there we are. It's all done. I need to set the time on it, and once I do that, it'll be ready to use. I'm still hoping to find that fourth wheel so that I can replace the second hand, because I do have a new second hand for it. I just couldn't find the wheel. If anybody's got a fourth wheel for a Unitas 6431 or 6445 that they'd like to sell, get in contact with me. I would like to buy it, because if I can find one, I'm going to take this back apart and put it in there. And what that would involve is taking off the train bridge so that I can access the fourth wheel, and I'll pull the old fourth wheel out, put the new one in, put the train bridge back on, and then put the back on, unscrew the front, put the second hand on, put the front back on, then we're done. And everything will be fully functional then. But I've got to find that fourth wheel before I can do any of that. So for right now, we're done with it until I can find a part. And it is functioning, it tells time, it just doesn't have a second hand.